Okay, let's begin the topic of graphing. And what graphing is all about is you're making a picture. And the picture is trying to find out if there's a connection or a link between two items. And in this particular example, I'm going to explore whether there's a link between the amount of sleep that a person gets and the test score that they receive. And so we build a simple data table. Now, whenever you list these two items, we have to identify what the units are that you're working with. For example, if you saw the numbers 8, 6, 4, 2, you wouldn't know what that means. Does this person sleep for 8 hours, 8 minutes, 8 days? You always have to write down the units that are involved. And in this case, we will write it down as hours. So this is how many hours the person slept. Now, when you have a test score, what if the scores that were showing up was, say, a 90, a 72, a 58, and these are totally made up numbers, and scores of a 45. Once again, is this the number that are correct out of 450 questions? 90 were right, 72 were right, or was this a percentage? What is it? So you have to indicate the units of those numbers in the data table itself. So now we have a set of numbers that connect these two items. 8 hours is connected to 90, 6 hours are connected to 72%, 4 hours connected to 58%. Now, looking at these numbers in and of themselves, you may start to think, there seems to be maybe a pattern here. The number of hours of sleep goes down and the amount of the test scores go down. So that's true. But what we'd like to do is get a full visual of this. And what's more, it'd be nice to know, so what is the score going to be if it was 3 hours of sleep? What if the sleep amount was 5.5 hours? What kind of test score? So these data points are anchors, but a graph is going to allow us to see all possible outcomes that might occur. Now, when we set a graph up, we always use a ruler and we create these two lines, which are called the x-axes, something that most are familiar with. And this will be the y-axis, and this will be the x-axis. You always use a ruler when you draw this. You do not freehand it. In this class, you're going to lose points if you do. So now what we have to do is what's called scale it. We have equal intervals along here, just like a football field. We have to have regular spacing between our items. Now what we do is we find out, so we're going to go by ones, 1, 2, 3, 4, 5, 6, 7, 8. Do we go by 2, 4, 6, 8? What is the scaling or interval value that we're going to assign here, and what is the interval or scaling that we assign here? Well, the first thing we're going to figure out is which of these items, amount of sleep or test score, is going to be on the x-axis. The rule here is that what goes on the x-axis is the measurement that the researcher had control over. It's the item that the researcher chooses to change. Now, the y-axis is going to be the value that that depends upon what the x value setting was. And the best way to illustrate that is that in this example, we're suggesting that the amount of sleep is going to impact on the test score. In other words, the test score is dependent upon the amount of sleep. One might suggest the other way around. Does the test score affect the sleep, or does the sleep affect the test score? And in this case, we're suggesting that the test score depends upon the amount of sleep, and therefore the test score is the dependent variable. And so we're going to write over here on the y, this is where you're going to always put the dependent variable. And in this case, you must label the axis as test score. And always, like we did in the data table, you have to label the units that are involved here, which is going to be, this is going to be percentage value. Now, that means that the amount of sleep that is gained is going to be the independent variable. And what that value is going to be is amount of sleep, and the units involved are going to be hours. Now, we're going to have to figure out what we're going to mark off as our intervals. And so going back to the original idea, which is we will start here at 0. Interesting enough, you don't always have to, but in this case we will. And we're going to go, right, we're going to create numbers or values such that when we reach the end of our line, when we run out of room, we have to have the largest value showing up. So for example, if we go by ones, 1, 2, 3, 4, 5, 6, 7, 8. Brilliant. If we go by ones, it allows the highest number, 8, to fit. Now you could say, but if I go by twos, it works also. 2, 4, 6, 8. See? It fits if I go by twos, but there's a problem. The problem is that all of this part of the graph space is not being used. The phrase we use is that the graph is going to be really squished into this amount here. So although 2 would work, it winds up being too compact of a graph. And so we're going to scale it as 1, 2, 3, 4. Now I have to number each one? Not really. I don't have to write down 5. I can write down here 6, and I know between here and here is number 5, and that saves me some work. So 6, this is 7. We know that, so this must be 8. So we can mark our intervals a bit more spread out. But it is important to realize that if from here to here is 1 hour, then from here to here has to be just 1 more hour. What I cannot do is go from 1 to 2 and from here go to 5. And I can't do that because that interval here is a greater amount of time than I set here, and that you cannot do. On one axis, the spacing has to be consistent. Now let's take a look here on the dependent side, or our test scores. Once again, our test scores have to get to a 90%. So if I go 1, 2, 3, 4, that's outrageous. It'll never work. What about 10s? 10, 20, 30, 40? Not close. What if I go by, say, 25s? 25, 50, 75, 100. Bonzo, that's the one. So I'm going to now label 25, 50, 75, and 100. So that is referred to as scaling. And a couple comments about that. From here to here on the x-axis, that spacing was worth a value of 1, 0 to 1. This one, the spacing was not worth just 1, it's worth 25. Am I allowed to do that? Absolutely. Because this axis is graphing a different property, test score, than this one, amount of sleep. But you must remember that on the same axis, if here to here is 25, then that same interval amount has to be another 25. So on the same axis, I need the same interval here. Same rule applies here. But this axis spacing does not have to be the same as this axis spacing. So what happens now is we can now plot our data. And we here see that there's 8 hours of sleep and the score is 90. Now this is going to get a bit complicated on my spreadsheet here, or my drawings here, but if I have 8, it takes me to here, and here I call what's called intercalate, or I estimate. If this is 75, that's 100. I'm going to estimate that 90 is right about here. And so I'm going to have a very crooked line, I'm sure. But let's see if I can get close to where I want to be. I'm not very good at this. So holy cow. It's very hard to do on this. So right here is our data point. This represents a relationship between hours of sleep and the test score. Now if we progress, and Mr. Kurth continues to do very poor drawing, but if we do, and roughly we can create that data point, and we can continue from there. Now what we then do is we drew what's referred to as, of course, it's called a best fit line. And we're going to now connect the data for this. And this is going to, again, be kind of difficult. But we change the color, and that's kind of cool. So this is referred to as a best fit, where we connect by a single line the dots for the data. Now, once we have this drawn, we are now able to do two things. We're able to, one, create an if-then statement. Now, what is the if-then statement in this case? And the answer is the if-then states if the independent variable does such and such, then the dependent variable does such and such. So for this graph, the if-then statement says if the amount of sleep goes up, then the test score goes up. And so that would be the written statement you would write. You would write, if amount of sleep goes up, then the test score will go up. And that basically is a summary statement that one makes about the relationship. The second thing that one is able to do besides the if-then is you are able to make a prediction. Now when you make a prediction, what happens is you choose a value for the independent variable, and it is a value that you did not measure. For example, in this particular study, the 3 hours of sleep was never measured. And so what happens is you ask the question, if the subject or person received 3 hours of sleep, then if your graph or data is valid, you can now predict what the test score should be. Now, what is the value of making a prediction? What a prediction allows you to do is it allows you to start to check if in fact your data, which resulted in this graph, is valid. It is a way of checking if the results are showing a true pattern. And what we mean by that is you never measured 3 hours of sleep. But if this line is accurately describing the relationship between these two items, then that line should be able to generate a value that was not measured. Now, if the prediction is then checked by actually having a person get 3 hours of sleep and actually then take the test and check the score, if the prediction is shown to be true, then that starts to generate good support that this data, this graph, is correctly linking or showing a connection between these values. If the prediction does not correctly show what happens if you go back and actually do it, then you start to wonder, you know what, this data may not be valid. So prediction is huge. One, it allows you to check if your data is in fact describing the relationship correctly. And second of all, it allows you to be able to predict or project what result should happen if you were to go back and do it. And these then are the essential pieces that go on in the construction of a graph.